So in the first two sections, we have a couple of overlapping concepts, but in some ways might not feel exactly the same. But we have our points, lines, and planes, and then we have our understanding of linear measurement. So let's look at the first question here. Name a line that contains the points T and P. So let's lock in T and P. What would be one way to name that line? The easiest way would be to name it as line G, right? This lowercase g here labels that line. Alternate ways to name it would be real simple way. If I know that those 2 points live on the line, it could definitely be line TP. N is also on the same line. They are all collinear, so we could use PN. We could use TN. All of these would be ways to name that line. I think the easiest way to do it would just be called line G. Remember, those lowercase script letters represent the lines. Okay. Name a line that intersects the plane containing points Q, N, and P. So the plane that contains points Q, N, and P, if we look, that's plane S. That's the plane they're talking about. It's really the only plane that's drawn here. So name the line that intersects that. Well, that would be this vertical line that comes down here. Remember, this dotted line means it's going through the plane. We're actually seeing through, like a see-through X-ray vision here. So that would be line J. Okay, you could also call it line MT. All right, I think, to me, I always like, whatever's simplest or easiest. So to me, one letter is easier than two and a symbol. Okay, all right. Try number 3 on your own. What would we name the plane that contains TN and QR? Look at those two lines, TN and QR, and tell me what plane contains them. So hopefully you look at the picture here and said, that would be plane S, okay? H is a line, G is a line, J is a line. The capital letters, the rest of the capital letters are all points. So that should have been, you should have said plane S. So on our actual quiz, we won't have to sketch anything by hand, but this is a good exercise to help us understand. And this is kind of a difficult one because we're going to have to go 3D on this. So I have two lines, AK and CG, and they're going to intersect at point M. I can picture that, but I want all of this to happen in plane T. So the first thing I'm going to do is go ahead and draw a plane. Okay, and what I like to do with that is label the plane T. Okay, so that T is going to just sit off in the corner there. And now let's see if we can do our two lines, AK and CG. So let's make this AK. It just means A has to live on that line, and so does K. And now I'm going to have this other line, CG, intersected. Okay, so there's AK and CG. They intersect, and they are going to intersect at point M. So I think I've covered everything that they asked me for there. Okay, all right, this next one. How many planes do we see in this figure? Well, I see this one bottom plane, A. Now, you might think that this bottom portion of the box is another plane, but it's not. It lives in A. All right, it's going to be part of A. A is sort of like the floor, and we have kind of this like hat box or odd-shaped trapezoidal shoebox sitting on top of it. So I have plane A taken care of there. Let me see if I can show you where the other planes are. See if I can get a different color here. How about this plane that lives up above it, parallel to it? It's sort of the ceiling. Okay, so we have plane A. That's one plane. We have the second plane, the blue plane that I drew here, and it's going to get kind of confusing if I keep going with the colors, but since this is a box, how many sides must we have to that box? We should have 4, right? The front, the back, and then the 2 sides. That would be 4. So I count 6 planes. Right? I have the top, the bottom. The bottom of the box lives in plane A, so that's only counts once. So that's 2, and then the 4 sides would give us 6 planes. Okay? Name 3 collinear points. So I can take any 2 points, and they're going to be collinear. Any 2 points I name are going to be collinear. So if I wanted to start that way, I could just take any 2 points that would be collinear, but then I'm going to need a third point that lives on the same line. So if I just arbitrarily said R and S, that's fine, and it'll be collinear, but it's going to be hard to find a third point that lives on that same line. It's not there. There's no other point that is on that line. So the only place where I can see 3 collinear points are right here. Let me see if I can get a different color here. Right here, M, X, and S. Okay. All right, so now let's try to answer the next one on our own. Are the points N, R, S, and W coplanar? Do they all live in the same plane? Look at where they are. Here's N, here's R, here's S, and then here's W. Do all 4 of those live in the same plane? Think about that and try to answer it in the Edpuzzle. Okay, so for the first 3 points, N, R, and S, I can see what plane they live in. They live in plane A. They're down here in A. W's up above that. He's not in the same plane, so no, right? N, R, S are in A, but W is not. Okay, so now we continue with our linear measurement section where you have a ruler. I'll do the number 1 with you, and then I'll let you try number 2 on your own in the Edpuzzle. So the first segment, EF, how many inches is that? Let's look and see. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's important. I'm at 11 there. 12, 13, 14, 15, 16. So we said that this was 11, but it's 11 what? 11/16ths, because each of those tick marks or hash marks is a 16th of an inch, because there's 16 of them to comprise 1, right? If I count from 0 to 1, you'll count 16 of those tick marks. So this is 1 and 11/16 inches. Okay? Be careful with the next one. Answer this in the Edpuzzle, but these are centimeters now, so they're not divided into 16ths. These are just tenths. Each little tick mark is a tenth. How long is this bar here, all the way up to here? What is that length? Answer that in your Edpuzzle. Okay, so hopefully we saw that we have at least 4 centimeters, and then we go a little bit further. 1, 2, and I wouldn't split hairs if you said 4.2 or 4.3. To me, it looks like it's 4.2 centimeters, okay, for the length of that one. So here we're going to have to do either a little addition or a little subtraction. In the first 2 cases, we're going to add. I have a smaller segment, and I want to find PS, trying to find the whole segment. So this is going to be 18.4 plus 4.7. Okay, we just add those 2 together. So that's going to be 23.1, and don't forget the centimeters. Okay, in the next one, we want AD again, so we have the smaller piece, we'll add them. This one over here, I want WX. So this is not, we can't add 100, it's not, the whole piece here is 100 centimeters. Okay, and then X to Y is 89.6. So it wouldn't make sense to add these two. It's not going to be 189.6 centimeters for this smaller piece. So think about that. I'm going to have you do that one on your own. This one we will have to add together. So I'll do this one with you because it's got the fractions that we love so much. So I'm going to just take this. I can see I have 3/8 and 1/4. That won't add to be more than a whole. So I'm going to rewrite this as 2 and 3/8 plus 1 and 2/8. We see that? So this is 2/8. 2 over 8 is the same as 1/4. And now I can go ahead and add them. 2 plus 1 is 3. And I can add the 8s. 3/8 and 2/8 is just 5/8. And this is in inches. Okay? So this one is not going to be addition. Why don't you give that one a shot and tell me what you get for the length of WX. So hopefully here we just took 100 minus 89.6, and that's 10.4 centimeters. Just subtraction there. Okay. Okay, so it's a little bit tougher now. We don't have a picture, but they tell us that K is between J and L. So what I should start off with in each of these cases is that JL equals JK plus KL. All right, So what I'm trying to picture here is J would live here, K is in between, and L's here. So it's a segment addition situation. Okay? So, and remember, we want to find X and KL. I want to find both of those. So they tell me here JL is 27. So there's going to be 2 steps to this. JK is 6X. So I substitute. And KL is 3X. So 2 steps. We have 27 equals 9X. And then we divide by 9. So X is 3, but I'm not done. They also want KL. So KL is 3X. So KL is 3X. That's 3 times 3. So now I've solved both parts. I have X equals 3, and I know that KL equals 9. Okay, so solve both parts. Try the next one. Remember your setup, right? Same thing I did over here. I want to start with JL. I'm going to start with JL equals JK plus KL. Okay, start with that and see if we can do 2 steps here. I want to solve for X and I want to solve for KL. 2 things. We want X and we want KL. Should be able to answer both of those. Give it a shot. Okay, so we have JL is 5x minus 10. A little bit tougher algebra here possibly. JK is 2x. And KL is x plus 2. So let's see how this sorts out. We have 5x minus 10 over here equals 3x plus 2. Now we want to collect all the x's on one side. So let's collect them where there's already more of them. So I have 2x minus 10 equals 2. Now I'm going to add 10 to both sides. So I have 2x equals 12. And simple solve here, divide by 2. I get x equals 6. So that's the first piece of this. Now I want KL. Well, it tells me up here that KL is x plus 2. So 6 plus 2. Oops, got ahead of myself there. 6 plus 2 is 8. 2 steps to that one. Okay, and the last part's pretty easy. To determine whether each pair of segments is congruent, it's yes or no. So TU and SW. Well, TU is 2 feet, SW is 3 feet. So that's no. Congruent means they have the same length. Okay, over here we have AD and BC. Are they the same length, AD and BC? Well, they're marked with these tick marks, so that's telling us that they are congruent. That's what those marks mean. Okay. Try this one on your own. Yes or no? Are they congruent? GF and FE. So here's GF with 1 tick mark and FE with 2 tick marks. Are they congruent? Yes or no? So hopefully we said no. 1 tick mark means that it's 6x and 2 tick marks means 5x. Well, clearly 5x and 6x can't possibly be equal unless x is 0, which means we would not have a geometric figure.